NASA's Voyager 1, humanity's most distant spacecraft, has started sending usable data back to Earth once again. Right now, this data includes health and engineering information, essentially updates on whether the spacecraft systems are functioning correctly, but this modest signal carries enormous implications. After a journey of more than 14 billion miles, Voyager 1 has ventured beyond the boundaries of our solar system and into interstellar space. What it's uncovering out there is reshaping our understanding of the cosmos. Space, long imagined as silent and still, is turning out to be anything but. Voyager 1 has detected a region filled with intense magnetic fields and strange energy waves, signals that space is buzzing with activity. One of the most surprising findings is the discovery of a powerful magnetic field at the edge of interstellar space, right where scientists expected the sun's influence to fade. Instead of a quiet transition, Voyager found a stronger and more chaotic force, disrupting prior assumptions about how the solar system ends and the galaxy begins. These findings are more than just scientific curiosities. They have real consequences. They challenge how we think about protecting Earth from cosmic radiation and planning future missions beyond our planetary neighborhood. Could this magnetic environment help us, or is it a threat we haven't fully grasped yet? But the magnetic field isn't the only surprise. As Voyager crossed into interstellar space, it encountered a sharp increase in cosmic rays, high-energy particles often associated with violent events like supernovas. We once believed the solar system provided a protective shield, but Voyager's data reveals that it may be weaker than we thought. This discovery brings up difficult questions. Are we truly prepared to send astronauts into deep space, where such radiation could be lethal? Do these cosmic rays hint at even greater hidden dangers in the vastness beyond? Adding to the mystery is what Voyager has detected at the heliopause, the boundary between the solar wind and interstellar space. Instead of a clean, stable transition, the spacecraft picked up erratic shifts in magnetic fields and plasma, behavior that defies current scientific models. These fluctuations could be evidence of unknown forces, forces that may have implications not only for interstellar travel, but even for safety here on Earth. As organizations like NASA and private companies such as SpaceX push further into space, with goals like colonizing Mars, Voyager's discoveries demand a re-evaluation of how we design and plan these missions. For over 4 decades, Voyager has stood as a symbol of human ambition and engineering brilliance. Even now, it continues to transmit data despite being so far away that each signal takes nearly 24 hours to reach us. This endurance is a testament to the careful planning that went into the mission, but it also reminds us that Voyager won't last forever. Its power is running low, and we may soon lose this vital source of deep space data. Still, what Voyager has revealed might revolutionize space exploration. Those strange magnetic shifts and high radiation levels could guide the development of new spacecraft shielding or even alternative propulsion technologies. If we understand these forces better, we might make space travel not only safer, but faster and more efficient. At the same time, these discoveries force us to confront the dangers of space. What if these forces are more than just natural phenomena? What if they pose a direct threat to human survival in space? As we pursue exploration, we must also prioritize protection and preparedness. The rising intensity of cosmic rays, for instance, isn't only a concern for astronauts. These energetic particles could disrupt satellites, GPS systems, and even global communications here on Earth. A spike in radiation from interstellar space could have far-reaching effects on the technologies we rely on daily. This reveals just how connected Earth is to the distant reaches of the galaxy, and how vulnerable we might be to cosmic forces we barely understand. There are also ethical questions to consider. How far should we push exploration when we still know so little about the risks? What responsibilities do we bear toward the astronauts who will face these unknowns head-on? Voyager has also revealed unexpected behavior in the interstellar medium, the mix of gas, dust, and energy between stars. Its instruments have detected peculiar changes in how solar wind interacts with this environment, suggesting forces we've never encountered before. Could these be remnants of ancient cosmic events or signs of phenomena entirely new to science? The answers may reshape how we understand the galaxy's formation and history, but they could also add new dangers to already risky missions to the Moon, Mars, and beyond. Still, it's not all bad news. Voyager's data could help develop technologies to shield future spacecraft from radiation or provide clues to new ways of traveling through space. Understanding these forces might even lead to breakthroughs in propulsion, allowing us to reach distant planets more quickly and safely. That's why Voyager's findings are both a wake-up call and a doorway to new opportunities. As space programs become more ambitious, and as private companies race toward destinations like Mars, the risks uncovered by Voyager must be addressed now, not later. Failing to do so could result in catastrophic outcomes, both for missions and for our life back on Earth. The Voyager missions have shown that exploration always comes with both risks and rewards. The surprises Voyager has delivered challenge us to think bigger, plan smarter, and explore more carefully. As humanity stands at the edge of a new era in space travel, Voyager's journey serves not only as a source of inspiration, but also as a warning. The universe is vast, unpredictable, and awe-inspiring, but it's also full of dangers we're only beginning to understand. The question is no longer whether we'll explore further. It's how we'll do it in a way that benefits all of humanity. Perhaps Voyager's most valuable legacy lies not just in its data, but in the questions it forces us to ask. What else is out there? Are we truly ready for it? And how can this knowledge help us build a better future on Earth and among the stars? This journey naturally takes us back to the beginning of space exploration. For most of human history, we could only gaze at the stars in wonder, imagining what lay beyond. But everything changed in the 20th century. Technology finally allowed us to turn dreams into action. The space age officially began in 1957 when the Soviet Union launched Sputnik 1, a small metal sphere that simply beeped from orbit, but proved we could put machines into space. Then, in 1961, Soviet cosmonaut Yuri Gagarin became the first human to orbit Earth, spending just 108 minutes in space, but making history. Not to be outdone, the United States soon followed with astronaut Alan Shepard's suborbital flight and then John Glenn's full orbit around the Earth. The rivalry between the US and the USSR pushed space exploration to extraordinary heights. In 1963, Valentina Tereshkova became the first woman in space, circling Earth 48 times over 3 days. But the most iconic moment came in 1969, when Neil Armstrong stepped onto the Moon during NASA's Apollo 11 mission, declaring, "That's one small step for man, one giant leap for mankind." From that point on, the focus shifted to longer missions. The Soviet Union launched the first space station, Salyut 1, in 1971. NASA followed with Skylab in 1973, allowing astronauts to live and work in space for extended periods. These early stations were testing grounds for the next big step, creating permanent homes in space. In 1981, NASA debuted the Space Shuttle program, revolutionizing space travel with reusable vehicles. Shuttles deployed satellites, repaired the Hubble Space Telescope, and helped build the International Space Station. But the shuttle era was not without tragedy. The Challenger disaster in 1986 and Columbia in 2003 were stark reminders of the risks astronauts face. The International Space Station, operational since the early 2000s, is a shining example of international collaboration. It serves as a lab for advanced research, from human biology and microgravity to preparing for future missions deeper into the solar system. It shows that space exploration is no longer a race. It's a joint effort to do the impossible. In 1’s recent years, private companies have entered the scene. SpaceX, led by Elon Musk, made headlines when its Crew Dragon spacecraft successfully transported astronauts to the ISS in 2020. This marked a turning point. Space was no longer the exclusive domain of governments. Other companies like Blue Origin and Virgin Galactic are now developing their own spacecraft, aiming to make space tourism a reality. Looking ahead, NASA's Artemis program is preparing to return humans to the moon, including the first woman and the next man. But this time, the goal isn't just a brief visit. It's to build a long-term base as a launch pad for Mars. That red planet represents the next giant leap, and both governments and companies are working on the technologies to get us there. Exploration has also brought countless benefits back to Earth. Satellites revolutionized communication, weather forecasting, and GPS. Research in orbit has led to advances in medicine, materials, and manufacturing. Every new mission brings discoveries that ripple through our lives, but our solar system is just the beginning. Beyond it lies a universe of strange and wonderful worlds. Some of the strangest planets ever discovered defy all expectations, like WASP 76b, where it literally rains molten iron, or LHS 3154b, a massive world orbiting a tiny star in a combination that has scientists baffled.